In example 3, the piecewise defined function is h of x is equal to 3 times x if x is not equal to 0, and 4 if x equals 0. Okay, so this one's a little bit different than the ones we've seen because in example 1 and example 2, the conditions, the if conditions, involved inequalities, so like less than or equal to, greater than or equal to. Here we've got equals and not equals, so it's a tad bit different. Okay, so let's think about what this is saying. Okay, there are two rules, so I'll go ahead and label them. So this is rule 1, and then this is rule 2. Okay, and basically, rule 1 holds most of the time, almost always. The only time rule 1 does not apply is if x equals 0. Okay, for rule 1 to apply, x cannot be 0. Okay, rule 2 only applies if x equals 0. Okay, so basically you can kind of think of this as rule 1 always applies except for one spot where x equals 0. Okay, so I'm going to do this one a bit differently. Okay, I'm not actually going to make a table of values. Okay, I'm going to go with this whole idea that rule 1 basically applies the whole time. So I'm going to graph rule 1 out in its entirety, and then I'm going to come back and deal with the one spot rule 1 does not hold at, if that makes sense. Okay, so let's take a look at rule 1 here. Okay, rule 1 is basically, remember, we've got h of x, that's the same thing as y, equals 3 times x. Okay, so this fits the bill of y equals mx plus b. Okay, so here this is going to be a line. The m value is 3 and the b value is 0 because you can write this as plus 0. Okay, so basically to graph this line out, okay, the y-intercept is going to be 0. And then to get additional points on the line, I just need to apply the slope of 3. Okay, so remember, if you've got 3 over 1, it is a positive slope, so this thing needs to be rising from left to right. And we know the rise is 3, the run is 1. Okay, so from the origin, that's the y-intercept, we're going to go up 3, right 1, up 3, right 1, and I'm going to keep doing this, up 3, right 1. Okay, if we go back to the origin, we can also reverse the direction. So from the origin, we can go down 3, left 1 to fill out the graph this way. Okay, so down 3, left 1, down 3, left 1. Okay, so this is the line. Okay, I'm going to go ahead and connect the dots. Okay, remember, this line holds all of the time except at one spot, x equals 0. Okay, so we're going to say this graph, we're going to put arrowheads on the endpoints, okay, because it continues forever in both directions. Okay, so that's rule 1, but I've got to account for the one problem spot. Okay, if we go back to this, 3x is the line. It holds everywhere except for x equals 0. Okay, so here's where x equals 0. That's the spot at the origin. Okay, we can't include the point. Okay, because this line does not hold if the x value is actually 0. So what we're going to have to do is come back to this spot and replace the closed circle with an open circle. Okay, now rule 1 is correct. The line y equals 3x is rule 1. It holds everywhere except at that one spot, x equals 0. The rule does not apply there. Okay, so hopefully that makes sense. Now we need to deal with rule 2, and it looks a little weird. Okay, it's just a number. There's no x. Okay, so we need to translate this. Okay, watch. Okay, so for rule 2, okay, look what it's saying. It only holds at one x value. It is saying if x is 0, then h of x, which is y equals 4. Okay, so rule 2 is just a point. It is the point 0, 4. Okay, and we want to include this point. Okay, so we're going to go to 0, 4, and we're going to put a closed circle. Okay, this is the graph. It consists of the red line with the hole at the origin and the point 0, 4, which is a closed circle. Okay, it is again saying that the rule is basically the red line except at x equals 0. At x equals 0, the rule is the dot. Okay, this is the graph. Okay, all right, so let's try to evaluate this function. Okay, we're going to find each of the following. Again, we are plugging in an x value and we need to be getting one output for every x value. Okay, by the way, that we needed to check and I forgot, but that reminded me. Does this pass the vertical line test? Yes. Okay, right here, if you imagine drawing vertical lines, the only questionable spot is through x equals 0. If you drew a vertical line through x equals 0, you would encounter both a closed circle and an open circle. Remember, the open circle doesn't count, so theoretically that vertical line would only go through the closed spot. Okay, so it would intersect your graph just in one single point. Okay, so we are passing the vertical line test here. We are good. All right, let's work on the evaluation here. Okay, so in h of -6, okay, that means the x value is -6. Okay, so again, you can look at the graph, you can look at the formula. Here's where x equals -6. If you go down to find the point on the graph, we're off the grid, so you do need to read this one from the equation. Okay, so remember here, basically the rule 1 is going to apply as long as your x value is not 0. Okay, so here the x value is -6. It's not 0, so rule 1 is going to apply. Okay, so we're going to do rule 1, which is 3x. So we're going to get 3 times the x value is -6. Okay, the answer is going to be -18 here. Okay, so basically if you did find the point on the graph at x equals -6, okay, that would be the point -6, -18. Okay, moving on to h of 0. Okay, so right here, in this case, x is 0. Okay, if we look at the graph, here's where x equals 0. That's where we're looking at both the closed circle and the open circle. The open circle is 0, 0, the origin. The closed circle is 0, 4. So both of those have an x value of 0. Okay, we have to go with the closed circle here because the open circle is not part of the graph. Okay, so that means that if x is 0, the output is going to be 4. Okay, that's the answer. Okay, again, if you looked at the equation, you have to go with rule 2 because x actually equals 0. Okay, so the answer would just be 4. Okay, so you would use rule 2 on this one. Okay, moving on to h equals 3, or sorry, h of 3. Your x value is going to be 3 here. Okay, again, you're going to use rule 1 because x is not 0 here, it's 3. Okay, so you would use the first rule, 3 times x. Okay, so you would do rule 1, which is 3x. So you would do 3 times x, x is 3, you should get 9. Okay, so the answer is 9 here. Okay, if you go to the graph, you could see this. Okay, so if x is 3, that's right here. Okay, find the point on the graph. Okay, that is 3, 9. So an input of 3 gives you an output of 9. Okay, lastly, we have h of 100. Okay, so here x is 100. Okay, 100 is obviously x value of 100 is not on our graph, so we have to use the equation. Okay, we need to use rule 1 because again your x value is not 0 here. Okay, so we would use rule 1, and that is once again 3x. So we're going to have 3 times the x value is 100. We would get 300 as the answer. Okay, and that makes sense because if you're way out here at 100, the y value is going to be way up in the sky. So 300 makes sense. All right, let's talk domain and range. Okay, again, our graph is in pieces. We have a line with a hole, and then we have a dot. Okay, so the domain and range might be a little tricky here. Okay, so let's start with domain. Okay, we need to track our x values. Okay, again, because this is in pieces, it might be in your best interest to make a number line. Okay, so let me draw a number line for domain. We're going to track the x values, okay, for domain. So we're just going to go to each rule, and we're going to kind of shade in the x values that each rule covers. Okay, so if we start with rule 1, okay, again, the key x value here is 0. That's kind of where things are changing. Rule 1 covers every single x value except for 0. So I'm going to put an open circle at 0, but shade everything else in. Okay, and then rule 2 comes in and covers what's going on at x equals 0. So we can shade in x equals 0. Okay, so the domain here, the entire number line is covered. So the domain here is all real numbers. Okay, the range. Okay, let's try to do the same thing for the range. Okay, so let me make another number line here. So for the range, we're going to be tracking y values. Okay, all right, so let's think about this. Let's start with rule 1. Okay, so the red line. Okay, for range, you need to be going from the bottom to the top, and you need to be writing down y values. Okay, so if we're traveling, we're starting way down here. Okay, the lowest point on the graph is going to be negative infinity. Okay, and then we're traveling. We get stopped at this open circle. The open circle is the origin. Okay, that has a y value of 0. Okay, so then after that, after we get out of the hole, we're good. All the y values continue on. We travel up to positive infinity. Okay, so that tells us that the red piece, okay, we do not get an output of 0 because the origin is omitted. Okay, but every other y value is covered by the red line. Okay, now let's see what the blue line does. Or sorry, the blue dot. The blue dot is just the 0.04. You're looking at y values. Okay, so the y value of 4, that's what the blue dot takes care of. Okay, so this is what the range looks like. All y values are being covered except for the y value 0. Okay, so if you had to write this in interval notation, you're going to go from left to right on this number line. Okay, you're coming from negative infinity, and then you travel until 0. You fall in a hole. Okay, 0 is not a valid output. Okay, so we have to exclude it with a parentheses. Okay, and then as soon as we dig ourselves out of the hole on the other side of 0, okay, we will travel off to positive infinity. Okay, so we need to pick up on the other side of 0, use a parentheses to continue to exclude it, and then we travel off to positive infinity. Okay, so your range is basically all real numbers except y equals 0. Okay, so that was a tricky one. Okay, make sure you go over that and let me know if you have questions. Okay, lastly, in part D, is this a continuous function? Can we draw this without picking up our pencil? Okay, go from left to right. Okay, if you're down here, you're traveling, you get stopped at the open circle. You have to pick up your pencil to go draw the blue dot. Okay, and then once you draw the blue dot, you have to pick up your pencil again to get on the rest of the red line. Okay, so the answer here is no. Okay, there is a discontinuity. Okay, where is it? All you have to do is write down the x value at which it happens. Okay, there is a discontinuity at x equals 0. Okay, because that's where we have to pick up our pencil. Okay, if we were traveling, we reach that open circle at the origin. Okay, that's where x equals 0. That's where we have to pick up our pencil to jump on the blue dot. Okay, so the function is continuous at every other x value. The only discontinuity, the only place you have to pick up your pencil is at x equals 0.